Welcome back, everyone. This is going to be lesson 2, matter moving through ecosystems. So last time we talked about energy moving through ecosystems. Today we're going to talk about matter moving through ecosystems. So first, we're going to start with what the heck is this biosphere? Okay, so that's going to be the combination of all the ecosystems in the whole world. Okay, so wherever life resides, we know that bio, the prefix bio means life, and so we know that biosphere means where life is. Okay, so there's two sections of that. There's going to be where energy flows through, like we talked about our food chains and food webs yesterday, and then matter is going to be cycles within. So we know that matter doesn't really leave Earth, except for, the occasional spaceship. But in general, we're not really getting matter from the universe, and we're not really giving it away either. Okay, so yesterday we talked about how energy is constantly replenished by the sun because it's an open system. We talked about GPP and NPP and then the 10% rule and things like that. Today we're going to talk about biogeochemical cycles, which are actually these closed systems of carbon cycle, nitrogen cycle, phosphorus cycle, which means that carbon, nitrogen, phosphorus, those things are not coming in and out. They are actually staying and cycling within the Earth's atmosphere, okay? So matter is going to be flowing between these things called pools of matter. The air, the atmosphere, is a huge pool of oxygen, otherwise we wouldn't be able to breathe, and also carbon dioxide because we are breathing. Water, there's water in the ocean. That's a pool of water. We usually think of a pool as water, which is kind of silly. And then organisms. Your body has a bunch of carbon in it. It has lots of carbon dioxide in it. It has oxygen and calcium in your teeth. And so you, as an organism, are technically a pool of matter. Okay? First, let's talk about the water cycle. Okay? The water cycle is pretty self-explanatory, and you've been studying it since the first grade, so I'm not going to go into depth here. Mostly I want to talk about the 1, 2, 3, 4, 5 steps, as well as the human impact, which is why I have my little dude here, the human impact on the water cycle. So hydrologic cycle, movement of water through the biosphere. Evaporation is liquid to gas. Condensation is gas going into clouds. Evapotranspiration. Evapo is going to be the evaporation piece. Transpiration is what happens on plants' leaves. Okay, so evaporation is liquid to gas. Transpiration is released from plants as a gas. Okay, so that's when water is released from plants as a gas. It's kind of the reason that dew happens in the morning. Okay, 4 is precipitation. Gas in clouds to liquid rain, snow, whatever, and then runoff, which goes across the land to rivers and oceans and then absorbed by soil as well. So what are we doing as people to affect the water cycle? Okay, every time we harvest a tree, like we talked about in the opening story with Haiti, there's going to be less evapotranspiration. Okay, so that means that there's going to be more runoff. So more mudslides, more running water across the land, and percolation. Okay, now percolation is when the water just kind of seeps down, like if it's raining up here, and then it's going to go into the soil and seeping down into like an aquifer or something. So like over here, you can see that this part is groundwater. If it rains up here on these different farms, if it rains, it's going to percolate down into the groundwater system. Okay, and the groundwater system is run by gravity. Okay, so increasing runoff, clear cutting leads to erosion and flooding. We talked about that in the opening story. And then paving land, like making roads, building buildings, and anything where we take regular land and make it concrete, we are going to lower the amount of percolation, which is going to increase the amount of runoff and evaporation. Now we're going to talk more about water diversion in chapter 9, And what I want you to understand is that runoff isn't always bad unless there's too much. Just like evaporation isn't bad unless there's not enough, and then it doesn't rain, and then we're having this drought like we're doing in California. Okay? A common misconception is that the water cycle and the hydrologic cycle are the same. Okay? They're not two separate cycles. Okay? Hydro means water. All right? Next, we have the carbon cycle. And I know you guys learned this in biology, so it is kind of a review. But we're going to have 6 different processes here in the carbon cycle. Number 1, we have photosynthesis. Carbon dioxide is converted to glucose. Respiration is the opposite. Glucose is converted to carbon dioxide. In the first lesson, we learned exactly how that works, so hopefully you remember that it's not as simple as this, but that's how we're going to think about it, because in the carbon cycle, all we care about is carbon. So carbon dioxide has carbon in it, glucose has carbon in it, so when we talk exclusively about the carbon cycle, that's what we want to talk about. Okay, then we have burial, which is basically burying carbon, which happens slow in sedimentary rock. That's like the different layers. Sedimentary rocks have layers, and I'll show you one of those here in just a little bit. 4 is extraction. We do that as humans. We extract carbon from oil wells and make that into fossil fuels. That's how we get fossil fuels. And then number 5 is exchange. Carbon dioxide is exchanged between the air and the ocean. Okay, so it dissolves into the ocean and then it's released into the air, because even fish and everything that lives in the ocean is going to be exhaling carbon dioxide. Now I know it's not through the air, but it's through the water. Okay, and the last but not least is combustions, which is burning of fossil fuels. That happens in energy factories, in your cars, anytime you see a lot of dirty smoke. Okay, historically, carbon dioxide in the atmosphere, ATM is atmosphere here, okay, has been at a stable level. However, since the Industrial Revolution, the carbon dioxide concentration in the atmosphere has severely increased, which is why later on we're going to be talking about global warming and climate change. Okay, all of that most of it is powered by the carbon cycle. Okay, so this YouTube video is really fantastic. It's a cartoon, which I think makes it even more accessible to everyone. Okay, so we have photosynthesis both in the water and on land. We have photosynthesis as well. We also have respiration on land and water. Okay, that's why there's 2 different circles here. We have let's see, number 3, we have burial. They're going to be buried in layers. So like millions of years ago, the dinosaurs were dead, and then their remains were buried over and over and over and over and over again, which is why then they turned into these things called fossil fuels. Fossils, fossil fuels, it should make a connection. Basically, it's dead organic matter that is now turned into oil, coal, and natural gas, and then we bring it up from the surface with using our fabulous oil rigs. We can do that on land and on water, and then we use it to power our factories and our cars and things like that. Now there can also be natural and human-caused fires that also adds carbon dioxide to the atmosphere. Okay, but that's always been going on. The difference between 1 million years ago and now is that there were fires, there were not factories. Okay? So, humans and carbon, what the heck are we doing? Okay, we are altering the carbon cycle 2 ways. First way is we are combusting fossil fuels. This releases old carbon into the atmosphere. Now, the carbon that we have over here in our trees, we have a bunch of carbon in our trees. If they're burned, okay, that carbon is pretty recent, okay? It was in the biosphere before, it's in the biosphere after it burns. However, this stuff from down here, this is old million-year-old carbon that the biosphere is not used to dealing with, so we don't really have a filter system for it. Okay, now carbon is a greenhouse gas, especially carbon dioxide and methane, and that's going to be raising our global temperature. We're going to talk about that more in chapter 19. Now, the other thing that we're doing as humans is we're harvesting trees, which means that we're cutting down trees, clear cutting, all kinds of things. Now, trees are actually excellent storage for carbon because they take it in and use it during photosynthesis. Okay? So the less carbon that the trees are able to store, the more there is going to stay in the air. Okay? So we like to have plants. Planting a tree is really helpful towards decreasing the amount of carbon dioxide in the air and keeping the global temperature a little more stable. Okay. All right, now we have nitrogen and phosphorus cycle. So let's see if I can fit this here on the screen both ways. Okay, so nitrogen cycle, we have 5 processes. Nitrogen fixation, which means we're taking the nitrogen from the atmosphere through biotic and abiotic processes and forming these 2 compounds. This top one is ammonia, NH3 is ammonia, NO3 is nitrate. Okay, so if bacteria is fixing nitrogen, it's going to turn into ammonia. If lightning is fixing nitrogen, it's going to turn into nitrate. Okay. Number 2 is going to be assimilation. Basically, it's taking up by organisms. I eat celery, and I'm assimilating that nitrogen. Okay, especially in like beans and legumes and things like that that actually fix nitrogen. Ammonification is basically the decomposition of nitrogen-containing wastes, and that can be fertilizer. There's nitrogen in fertilizer, mostly. Okay, so any fertilizer is decomposed, and that turns into ammonium. Okay, so ammonification is ammonium. It's just one extra hydrogen compound there. So ammonia is NH3, ammonium is NH4. Okay, number 4 is going to be nitrification. That's done by bacteria. It's going to be breaking down NH4, converting it to nitrite and then to nitrate, because really the biggest reason that we need nitrogen is for this nitrate. Okay, and then denitrification done by bacteria again. That's going to take this stuff that's down here, this nitrate that we're using as organisms, and turning it back into something that is in the atmosphere. Okay, so over here we have nitrogen fixation. We have our N2 molecule right here. We have nitrogen fixation, can go 2 ways, by lightning, okay, or other abiotic processes like creating it in a fertilizer factory, or by bacteria. Okay, so just like I said before, the abiotic processes turn it into nitrate right away. The biotic turns it into ammonia. Okay, and then it's turned into ammonium, decomposers, ammonification, assimilation, assimilation again. So assimilation can go into plants or into animals. Okay? This video is also very good if you're more of a visual learner like me. Okay, now what are people doing to nitrogen, with nitrogen? Leaching. Okay? Leaching, kind of like a leech gets stuck on your skin and just sucks all of the blood out of you. What happens is if too much nitrogen gets in the soil and the plants can't take it up, it's then kept in the soil for even longer, and it can have negative effects on the ecosystem. Okay? Now, nitrogen is usually the limiting nutrients in soils and different farms and places like that. Usually there's not enough to grow as much as we'd really like, which is why humans invented fertilizer. So they said, oh, I have this piece of land, there's not enough nitrogen in it, so I'm going to take this poop from over here with my cows and stick it onto the farmland. Okay? Now, there was a couple of results from that. More nitrogen leads to a decrease in the number of species due to competition. So species that really like a lot of nitrogen are really going to thrive on nitrogen, and those who don't need very much are going to be kind of over-competed, so they're going to be kind of taken over. Okay? Additional nitrogen in some places leads to an increase in nitrogen in other places. So if it gets into the water, it's going to move downstream. It's going to get all the way to the ocean in some cases. And so this kind of negative effect kind of moves on and on and on and on down the river ecosystem. Okay, so the moral of that story is that the addition of extra nutrients does not always mean a positive result for the ecosystem. So you might think, oh, more nitrogen is awesome, more nitrogen is better, I want more nitrogen. No, you don't. Okay, because sometimes it's too much of a good thing, you know. Okay, next we have phosphorus. We have just 5. And what's special about the phosphorus cycle is that there's actually no atmospheric component. So there's no like in the carbon cycle, there's carbon dioxide in the atmosphere and methane in the atmosphere. In the nitrogen cycle, there is nitrogen gas in the atmosphere. But in phosphorus, there's nothing in the atmosphere. Okay, so that kind of takes the atmosphere completely out of the picture in this case. So first we have weathering, snow, rain, downing, like water gets on rocks and it moves these rocks, turns them into soil and moves them downstream, usually downhill. Fertilizer and detergent. Fertilizer, in addition to nitrogen, also has phosphorus in it. Your detergent that you use to wash your clothes in the washing machine used to have a lot of phosphates in it, and that was actually bad because then it got into the water system, and again, too much of a good thing. Okay, it created these algae blooms and these hypoxic conditions and these dead zones. Okay, we'll talk about that in just a second. So they don't use as much phosphorus as they used to. So what happens with this is that we mine the phosphorus, we use it in fertilizer or detergent, and then it goes into the soil and into the water. Okay, excretion means mostly poop. And decomposition, when things die, and that's animals and plants, gets into the soil and the water again. Okay, dissolved phosphorus is going to be in ocean sediments. Okay, so nitrogen can dissolve into the water, carbon can dissolve into water, and phosphorus can dissolve into the water as well. And then our last process is just kind of geology. Like we know plate tectonics, we know that mountains change and they're built and they're leveled out and all kinds of stuff happening over millions and millions of years. So that's going to be lifting these phosphorus rocks from the ocean into the mountains. And I'll show you a picture of that in just a second. Actually, right now, before we talk about people. Okay, so in our phosphorus cycle, okay, we have weathering. It's coming down from the top, down into the water. It goes over land. It goes into the plants. It goes into the water. Okay, phosphate fertilizer is mined here. So we took this top off of this mountain and we're mining all the phosphorus in it to make fertilizer. Okay, and then that goes on to the crops, onto this farmland. Okay, and so the extras is going to go into the water through runoff. It's going to go into the soil through leaching. Okay, animals, when they poop and when they die, they're going to do the excretion and decomposition, and that's going to put even more phosphorus onto the land and into the water. Okay, and then these geologic forces are going to take all of this, the phosphate rocks that's at the bottom of the ocean from all the dead fish and stuff, and make it into a mountain. I mean, that happens over millions and millions of years, but eventually, through plate tectonics, this might eventually be up here, so you never know. Okay, so again, the same process that's happening here in the water is also happening over here on land. Okay, now people and phosphorus. Nitrogen is usually the limiting nutrient on land. Phosphorus is the limiting nutrient in the water. Okay, so that's a very important distinction. All right, the sources are going to be fertilizer and household detergents. So when people use too much fertilizer that their plants don't need, or they use detergents that have too much phosphate, or they're washing their cars using phosphate detergents and then not, because now they make really cool biodegradable car washing soap, so that when you're washing your car and you're the water is going out into the street and into the gutter and then to the river. Okay, historically that's been adding even more phosphorus to the river, but now we have biodegradable kinds. It breaks it down, it doesn't use phosphates, and so that's not affecting the rivers and stuff as much, which is fabulous. Okay, so the more phosphorus in the water means more producers because they have more food to eat. Okay, yay, algae. Everyone, algae, coming to dinner right now because we have a bunch to eat. Okay, now that causes this thing called an algae bloom. Looks like that. Okay, the water turns green. It looks like it has this nasty green film on it. Okay, so then everything underneath it dies because if the sun is blocked out, then the plants that would normally be at the bottom of the lake or the river or whatever now don't have anything to convert into photosynthesis. Now there's no oxygen. Now all the fish are dead. Okay, and as things die, they actually use up even more oxygen. So there's no more oxygen being produced, and everything dying is making even less oxygen available, okay, which creates this thing called a hypoxic condition. So we know the oxy is going to be oxygen. Hypo is low or without. So hypoxic is going to be low oxygen conditions, which leads to fish kills, and then that's what you'll see, like all the fish, the dead fish washing up on the shoreline, and then dead zones. Okay, it can also create this thing called a red tide. Okay, with everything dying. All right, so phosphorus cycle video, algae bloom video, and then we also have calcium, magnesium, potassium, and sulfur. The most important one in this case is going to be the sulfur cycle, okay, because we need sulfur to make sure that we have proteins in our body, and it makes us able to use oxygen. Okay, so without sulfur, we would not be able to use oxygen. Even if we had plenty of oxygen in the air or in the water, we wouldn't be able to use it without sulfur. Okay, so we have carbon in almost every cell and every tissue in your body. You have nitrogen in your DNA and phosphorus in your DNA, as well as ATP, your energy source for all your muscles and everything. That the P in ATP stands for phosphorus, so that's why those three are important in your body. So sulfur cycle works similarly to all of these. So we have the weathering, just like the phosphorus cycle. Okay, sulfur is trapped into rocks until it rains so hard that it's released. Okay, assimilation, just like the nitrogen cycle. Okay, where it moves up the food web. There's also an atmospheric component. Sulfur comes out of volcanic eruptions, and sulfur comes out of the burning of fossil fuels, which is why it smells so bad. Okay, and that's SO4. That's sulfurous oxide. And then when those two react together in the atmosphere, you get this sulfuric acid, which creates acid rain. Okay, so if anyone asks you and they say, hey, what cycle produces acid rain? Oh yeah, the sulfur cycle. Okay, because the sulfur in the atmosphere reacts with water, creates an acid. We know it's an acid because it has hydrogen in front of it. So the more acid rain and acid precipitation that we have, the less amount of water, okay, that we have in the ecosystems. Okay, so the more people we have, the more phosphorus, the more human-produced phosphorus that we have, the lower amount of clean, usable water that's not laced with acid is going to be available for our ecosystems. Okay, so today there's only 3 questions for your WISC, and then next week we will do our last lesson. Okay.